Okay, so integration. Generally, it takes this form to say that if you want to find the area under a curve, usually between 2 points A and B of some function f of x with respect to x, then we will use the integration. These are the limits of my integration, and if I want to show that on a graph, let's just say I have a curve going whichever direction, and I have a point A and a point B, and I want to find the area under the graph between this space. Let me just shade that in. So that's the area between that space. Then whatever function this graph takes, I will integrate that function over here with respect to x, because these are all numbers on the x-axis. Obviously, as integration becomes more and more difficult, you could end up changing what you're differentiating with respect to. All right, so let's see the general format for integration then. If I have to integrate some x to the power n with respect to x, then what this does, my integration would become, you add 1 to the power of n, so now you have x to the power of n plus 1, and whatever that answer was, I will now divide it by my original function there. And because this is going to be an indefinite integral, I need to add a constant c, because there could be a constant in there. Now, I just said indefinite integral. When you don't have any limits there or there, which in some cases you might not have, then what you have is an indefinite integral. Okay, so you must add that plus c. But if you do have limits, you don't need that on the end, because once you integrate, then everything works itself out. All right, all of that is just jibber jabber until we actually see an example. So let's start nice and simple. Let's just say I want to integrate a function x with respect to x. That's just one x I've got there, okay? So if we follow the rule that's here, the power that this x has got is 1, but you don't see that power, but it's there, okay? So what I'm going to do now to follow the rule, this then approximates to x to the power of 2. Remember, the power of 1, I will now add 1 to it, and then I'm going to divide by that power, and I'm going to put a constant on the end, and that is done. It is that simple. All we do is add 1 to the power and divide by that new power, and you're done. Okay, that's pretty straightforward, right? Okay, let's start looking at just a slightly more complex problem. So for this one, I'm going to do integration of 4x cubed, okay, with respect to x. Always say what you're differentiating with respect to. So this is an indefinite integral. Right, let's go. I'm going to ignore that 4 for now. I'm just going to leave it there, all right? Keep my x, add 1 to the power. So that 3 now becomes a 4. Divide by that new power plus some constant c. Okay? You can now see 4 and 4. They're going to go because they're going to cancel each other out. So the final answer to this now is x to the power 4 plus c. All right? Let's do one more like this, and then we will look at some definite integrals and see what we've got. Okay, this one's a little bit longer, but feel free to pause the video and have a go on your own. Don't worry about the fact that it's in parts. You can do it all in one go. I'll just write a bit of an aside here. Some people prefer doing integral of 9x squared dx minus the integral of 4x dx minus the integral of 5 dx and so on. If you want, you can do that. I will not be doing that. That's too much work, okay? You can just basically look at it just from here and integrate it. So let's go. Keep that 9. So I'm just going to write the 9 down. And then I'm going to add 1 to that power. That becomes a 3, and I divide by 3. Take away, keep that 4. That x here has a power of 1, so I'll add 1 to it. It becomes 2. And divide by that new power. Minus, keep that 5. Now, here's the tricky bit. You might be asking yourself, well, where is the x? There is no x, so what do we do? Well, there is an x. The x is there. It is x to the power 0. Okay? Now, we already know, let's do this, blow this up now over there. X to the power 0, we already know, is 1. Any number to the power 0 is 1. So that x is actually there, multiplying by that 5. I am now about to add 1 to that 0 to give me now x to the power 1. I'm actually also dividing by 1, but there's no need to write it there. So there's a 1 here, okay? Plus some constant c, because this is an indefinite integral. All right, cool. Well, we can simplify a few things, can't we? This 3 will cancel out into that 9 3 times. This 2 will cancel out into that 4 2 times. And that 5 is on its own. So let's write the simplified version. Simplified version says we're going to have 3x cubed minus 2x squared minus 5x plus some constant c. And this is now done. All right, so you can go now and try to integrate some easy things. You can sometimes get things with square roots. You might sometimes get things with negative numbers. All you got to do is just reciprocate where possible. Change your square roots to the power of a half, and you will be okay. So, for example, if you're given something like, oh, I don't know, integrate the square root of x dx. I'm not going to do it through, but all you do is change that square root to x to the power of a half, if you know that already, and then do your plus 1 and then divide and so on as normal. What I want to do now is, what do you do when you have definite integrals? Okay, so here we have a definite integral. I know it's a definite integral because there are limits on it. Okay, so it's basically now that we have a curve of some sort of curve. Don't know how that's going to look, but it's between 1 and 3, and we're trying to find the area underneath the graph there. Now, bearing in mind, I'm not saying that the curve will look like that. I'm just drawing something to demonstrate here. So that's what we're finding. This is a definite integral. Now, here we go. So let's integrate it first, and this time you're going to notice I'm going to use big square brackets. Okay, I just like using them. So keep your 2. If you want, it actually might be a good idea to pause the video here and see if you can have a go on your own. But yeah, keep your 2. Add 1 to the power of x, that becomes 4. Divide that by 4. And then plus, keep the 5, add 1 to the power of x becomes 2. Divide that by 2. And this time I'm going to put my limit just on the outside there. Let's simplify things. So this 2 cancels out into that 4 2 times. So what we've got left now is x to the power 4 over 2 plus 5x squared over 2. And we're dealing with limits of 1 and 3. Okay. What do you do with the limits? Well, you need to substitute the limits in. The top limit is always the bigger one, so we're going to put that in first. So everywhere where there is x, I'm going to replace it with the number 3. There's an x there, and there's an x there. I'll put these in brackets to make a point as well. So 3 to the power 4 over 2 plus 5 times 3 square over 2 and I've substituted now all of the x's with 3's. Okay, now I'm going to subtract. You always subtract this bit. Now I'm going to substitute the lower limit, which is the 1. So replace all the x's with 1's. Okay, so x to the power, let's undo that. So 1 to the power 4 over 2 plus 5 times 1 square over 2, and that is now done. Now let me just emphasize this point. You always take away here, okay? You take your top limit, you put that in, and then you subtract the substitution of the bottom limit there. Okay, right, this is now a matter for, I don't know, I guess the brain or the calculator. So we're going to have 81 over 2 plus 3 squared is 9, 45 over 2, and we're going to then subtract from that a half plus 5 over 2. All right, that's up to you, whatever you do, but the answer is 60 units square. All right, okay, I think that is just about all that I'm willing to do in this first video for integration. Don't forget, this is a much more accurate way of finding the area on the graphs. Also remember what to do with those powers. Be very, very careful with them. Sometimes some questions could be a little bit nasty, where you might be integrating something like, oh, I don't know, just a random one, minus 2/3 or something like that with respect to x. Just follow the rules. All you got to remember is to add 1 to it and then divide it by that same power, that new power that you've now got. Be careful with the fractions and you will be okay. One last thing to mention: if you have a curve, all right, let's just say you have a curve, when you, let's just say this curve is f of x, when you differentiate that curve, as in finding f dash x or dy dx, depending on what you've got, if you differentiate at a point, you're actually finding the gradient at that point. When you're integrating f of x, you're actually finding the area under the graph depending on where it is. Okay, so if you have limits, great. If you don't, then you're just basically shooting in the dark, but you're finding a general form of it. But the last thing that I can mention to you is, if you integrate something you have differentiated, you are actually bringing it right back to its original state. Okay, so you're bringing it back to y or f of x, depending on what it is that you had. All right, so integration is the opposite of differentiation and vice versa. So if you've differentiated something and you want to get back the original form of the function, you integrate it to do that. All right, so I hope you guys liked this video. I hope that it was pretty helpful to you. Feel free to press that like button and subscribe if you want to keep up to date with future videos that I've got on there. Okay.